It's time. We must look at the definition of the derivative, also known as the long oogie way. First off, let's remind ourselves, the derivative of a function is a function itself. There are a couple different ways to denote it. We've got y equals f of x. We can say f prime of x. We can say y prime. We can say dy dx. So why do we have these two, and these are basically the same, two different notations? Well, that's because Gottfried Wilhelm Leibniz and Isaac Newton both created calculus, or invented calculus, around the same time. Why, you might ask yourself, have you not really heard of Gottfried Wilhelm Leibniz, but you have heard of Isaac Newton? Well, because Isaac Newton had much better PR people, basically. He was really good about tooting his own horn. So let's get into this. So here we have your average Joe function. I would like to find the derivative at this point A. I'm going to go over a little bit of distance at x plus h and draw our line. This is clearly not a tangent line. It's a pretty crappy approximation, but that's where we're going to start. The slope of this line, well, slope is rise over run, which is change in y over change in x, which in this case is f of a plus h minus f of a over a plus h minus h, which simplifies to f of a plus h minus f of a all over h. Now, as I said, this is a pretty crappy approximation, so we want to make h a little smaller. Let's try that one. A little bit closer, still kind of crappy. How about this one? Still pretty crappy. We're getting better there. But notice what we're doing is, here was my a plus h, and now my a plus h is here. So what we are doing is we're taking the limit as h approaches 0 of that difference quotient. This is known as the difference quotient. And if I want the general equation for the derivative, that's f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. And that's your handy-dandy definition. Let's look at an example. Suppose I have f of x equals x squared minus x. I want to find the derivative, which is, again, the limit as h approaches 0 of f of x plus h minus f of x all over h. When we plug it in, we get x plus h squared minus x plus h minus the quantity x squared minus h. If we try to plug 0 in, we're going to get a 0 over 0, which we know is bad. We need to simplify this expression, and hopefully the h's will cancel out. So multiply the top out. Oops, I left a bracket, sorry. Multiply the top out. We notice that the x squareds will subtract off and the x's will subtract off. If the terms that don't have h's don't subtract off, you did something wrong. So go back and double check. With what's left over, each term has an h, which I can factor out, and then cancel. I can put 0 in for the leftovers, and I'll get 2x minus 1. So when you're doing the definition of the derivative, almost all of these cases are simplify, cancel out the h, plug in the leftovers. And that's how you would find the derivative of a function.